You want to quickly,
L-
do you want to quickly go to the pipes, or if I take time, is it okay?
I so I don't understand. Like, are you going to take time? Like, you are going somewhere
No,
else?
no, no. So, no, no. In between, before going to the pipe,
Yeah,
can we add one more block on the above
yeah,
for the channel flow,
yeah,
so that I can able to teach you the cyclic patch type?
yeah. We can.
So in the last meeting, you are saying that I would want to go to pipe flow quickly. I
Yeah,
heard that.
yeah. But at least we should know the basic things before like going to other things.
Yeah, yeah. I'm not sure. So have you gone through this? Actually, I shared the notepad file with you for this case, right?
Yeah, only for the mesh block.
Yeah, only for the mesh block. We are not going to simulate this one because it will be not laminar. This is turbulent flow.
Yeah. So why not we should simulate this as well?
Yeah.
Maybe
So
not.
first of all, for initial we will complete laminar flow. So then we will go to turbulence because I can directly teach you K epsilon, K omega properties there itself. So if I teach right away, it will be little bit confusing because
Okay.
the basic part which we are going to solve, create mesh. The major part here in Openfoam is creating the block mesh dit. That
Yeah.
is the
Mm-hmm.
that is a major part in the open form if you want to understand, because the remaining all things are same. So u and p value you can give it, so whichever side is velocity is there. So how you defining the phases, that is the most important thing in the open form.
And for laminar and turbulent, will the mesh
Yeah,
be different? Like,
yeah,
is
mesh is same, that's why I'm only telling you the mesh file, not for the simulation part. And
so? Mm-hmm.
icoform can't able to solve the turbulence. So
Oh,
did I actually shared you the file about the different types of foams and what are their capabilities?
no, no, no.
Oh, okay. On the starting class, I told you, right? I have notes, so I will share with you. So, icofoam can't able to solve the turbulence flow, so we have to change the solver as well for that.
And what is the solver for the turbulent flows?
Simple foam you can so use it. Simple and pimple foam you can use it to solve the turbulence.
Okay, okay. We. I have another case to show you for the turbulent flow, but maybe later in the last 10 to 15 minutes, I will save this for the turbulent flow questions. I have a lot. So
Okay.
yeah, yeah. So
Okay. So
share.
can we start?
Yeah, because I was still thinking that the icoform is used to solve the turbulent flow. But thank you just telling me, and please share me the notes so that I can go through and see like which form is basically, because my
Yeah,
whole purpose is to work on a turbulent flows. But
yeah.
laminar is
Icofoam can't able to solve.
yeah, laminar is basically the basics, and we all have to go through the laminar flows. Yeah.
Yes.
Okay.
So I have multi-block. Do you want me to send the notepad file again, or else you want to create here in this class itself?
Okay, let's create here, or maybe you can share me so that I can have both. And but is the multi block is the same way that we created
No,
the
no, it is not the same way actually. So it is a little bit different. So if you want me to share, I will share.
but let's go through this also.
Which one?
But we also go through this like in the class today as well.
Okay. So you want the multi-block to be sim block mesh it to be created here itself, right?
Yeah.
So okay, then close it.
You want to share it?
You are sharing already. You
Yeah.
want to try it, right?
Oh, yeah. So
So I
I
will
hope.
guide you. You type it on yourself.
Yeah, okay. You mean I should close this paragraph? Why?
Yes.
Why?
I think there is a update down there, but you can open terminal and try with Control C. Can you able to close it or not?
Why is this happening? The emotion.
Open Ubuntu. Yeah,
Winter.
that terminal. Yeah, control. It's already closed, I think. Yeah, it's again giving the same error. You have to restart, I think so.
Oh my gosh. Let me. Is there any other way to close this? Should I restart it? Okay. Uh, okay, let me restart it. And meanwhile, you can share the shutdown restart.
You want me to share which one?
And the one that we are going to do now as well,
Okay, okay, okay,
and the notes as well.
okay, okay.
Uh-huh.
You want me to share through email, right?
Yeah, email would be good. It would be good. Updates are underway. Please keep your computer on. Shit. Uh-huh. Why updates are underway? Hmm. How was your Diwali? Happy Diwali, bro.
Yeah, thank you, man. Are
Mm.
you celebrating Diwali over there?
I haven't seen any kind of a festival right now. Oh, yeah.
Okay, I will send the currently which we are going to solve here.
Mhm.
Yeah, I have created and shared you the file directly to you through email.
Okay.
Go through that one, and I will now share the notes.
You share multi-block. Yeah.
Hmm.
50.
I just shared you the file of solver capabilities.
Okay. Now what should I open? Okay.
You are sharing your screen or just a second?
Yeah,
I'm
yeah.
unable to see your
Oh,
updates. Are
haven't opened a Zoom here. Okay, let me. Yeah. So yeah. Now, yeah, you can see the screen now. I guess so. So
one second. Mm, yeah, I'm able to see. Okay, so create one copy folder. So initially we created for a single block, right? So copy the same folder.
Mhm. Copy the same folder. This one.
Yeah, copy the same folder and rename it as a multi-block, channel multi-block.
Yeah, channel 33. Then quality. Okay.
So okay, so if you have any AutoCAD or any Fusion 360 in your desktop for drawing purpose.
We, no, which one is there anyone like last time I was thinking to install Salome.
What is Silo? What is that?
Salome, Salome, Salome is also for a 3D CAD and it's for like drawing this the open source geometry creating software like this one. I thought you
So you have university. Don't you have a don't you your university have what is it called? Fusion 360 or AutoCAD educational version?
yeah probably they might have. I need to ask them and ask them to install it.
Okay, okay. So just are you good with the PPTs and Word files? So I just wanted to create the block of the geometry which we are currently have to work.
Yeah, you can. Yeah, until yeah, if you can create it, then it's good. I will ask them today as well for the which software would be good. AutoCAD, do you think is a good? I don't
No,
know.
AutoCAD. Fusion 360 will be better. It will be easier. AutoCAD, you have to learn that one also. If you want to draw anything or if you want to do dimensioning and everything. Fusion 360.
Okay, yeah, because I used to like draw drawings previously on a SolidWorks, but
Yeah, SolidWorks is also fine. Sorry, if you know Solid, if you have SolidWorks in the desktop, that is also very good. Anything is fine.
okay, okay. Right now I don't have, but I will ask them if they can install. Otherwise, I will have to bring my laptop because it's in my laptop, the SolidWorks. So, do we need today the?
No, 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 no need, no need. Just you understand the picture, right? So I will quickly draw the picture and upload it in the chat box. That will be fine. Or else, if you want to create it on a what is it called PPT, it will take time.
Yeah, okay, yeah, okay.
So just open the blockmesh date. So what we are currently doing is we are dividing the block which is having 2 meters of height, right?
Yeah, okay.
And 4 meters of width
Yeah, yeah,
and 2 meters of what is that called? 4 meters of length, 2 meters of width, and 2 meters of breadth.
yeah.
So we are dividing it into half. We are making it a single block into multi-block.
Hmm. Yeah,
Okay. So open the blockmeshit file. Yeah, open it, right?
yeah,
So change from vertices,
yeah,
delete this one. This is
the,
the new one, right?
yeah.
I mean, channel multi-block, right? So delete from vertices and
Uh,
paste is the one which I given. In the meanwhile, I will draw the diagram for you.
and the one that now you share. Okay,
Yes, yes.
okay, okay. From what is, but you only change the this portion, the simple
No,
grading.
no, 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 no. You go down there. You go down there. On the boundary side, you will be able to see the changes.
Okay, okay, okay. 400, 4000. Okay, you created this one.
No, 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 no. This is not a multi-block vertices. Is this?
No,
Yeah,
this
yeah, yeah. This is the
now.
earlier one, right?
Yeah.
Change everything. Change everything from vertices.
Okay, from vertices to the bottom.
Yeah, vertices to the bottom. Delete everything.
The bottom. Yeah. Okay. Control S. Yeah, we changed everything. Yeah. Now we have a 004001. That means vertically one, you cut it. Then let me try it quickly on my own as well. Our plan. 0000 400 and 410 422. This is 412 410 410 020 020. Okay, 4420. Yeah. Mhm. Are you drawing?
Yeah, yeah.
Okay.
For sending you in the chat box. You have mobile, right?
Yeah, yeah.
I'm sharing it in mobile.
Are you sharing on WhatsApp?
Yes.
Okay. Let me open the log. Yeah.
Can you open it and able to understand? Not good at drawings. Huh?
Yeah, I got it. Yeah.
So these are the. So if you give me the remote control access, so then I can
Yeah.
explain.
You can ask.
Yes, yes, yes.
Push the button.
I just requested.
Yeah. Okay. This one.
Yeah.
Yeah.
0, 1,
Just a minute.
2, 3. Yes.
Okay. Stop recording. Okay, we recording. Yeah. Yeah. Mm, The control is with you now.
Yes, yes, yes. Sorry. This is the full screen.
Yeah.
Oh, okay. 0, 1, 2, 3 on the back side of the cubicle box, cubicle channel here.
Yeah.
Typically 0, 1, 2, 3 and 6, 7, 8, 9 is the front face of the block, bottom block.
Yeah. Okay.
Okay. 2, 3, 4, 5 and 8, 9, 10, 11
Yeah.
is the second block, back and front faces.
True.
So here, so what is the main case in this block is, so initially this is combinedly one block 0, 1, 4, 5, 6, 7, 10, 11.
Yeah.
This is the complete block initially. So previous case, here we are dividing it into the half. So here 4, 5, 10, 11 and 0, 1, 6, 7 are the top and bottom faces. Okay, that will be like a fixed wall type.
Yeah.
Okay, okay, and the inlet will be, our inlets will be 0 to 8, 6 and 2, 4, 10, 8.
Uh-huh.
These are the inlets, and 1, 3, 9, 7 and 3, 5, 11, 9. These are the outlets.
Uh-huh.
Okay. So with reference to this one, quickly go to the block mesh dit file where it is actually. Here it is.
Yeah, just a minute. Have you got, let me pull it over here. I think it's on this. Give me a minute.
Yeah.
Is this the file?
Yes, yes, yes.
Yeah.
Yeah.
Um,
Why it is not scrolling down? Do you have the access?
system. Mm, yes, now you have the access.
But I'm unable to drag it down.
And do you now? Yeah,
No,
now,
no. I just want to scroll down,
yeah.
but here it is not. Yes,
Maybe,
yes, yes. No, no, no. Okay. So here we created the, you understand the vertices part, right? 0, 0, 0. This will be this one. And so you can, for understanding, you can write it here, like simply type hashtag.
yeah, just comment.
Yes. So that will be our vertices one. Similarly, you can write it over here, hashtag, if you want it. But as of now, I think you can able to understand because I already passed the 4 classes. So this will be our 0, 0, 0,
Mm-hmm.
and 1 will be our 4. So 0 to 1, that distance will be 4 meters. Okay, 4,
Mm-hmm.
0, 0, and 0, 1, 0, that will be vertices 2 here,
Mm-hmm.
and 4, 1, that will be here,
Okay.
vertices 3. So next our 4 will be 0, 2. That means 0 to 4, the height will be 2. Okay.
Yeah.
So similarly, we have to write it for every vertices here.
Yeah.
So till 4 to 0, I tell you the shortcut, right? So if you create either backside or front side, you can repeat it again with the same, with the length of the z.
Yeah. 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 Z is a two here.
So z is 2 here. So that's where. So after this one, everything is same on the bottom side, but with the z on 2.
Yeah. And
Okay.
yeah, we just go laterally, span wise.
Yes.
Yeah.
Yes. So the first one will be our back face. So second will be our front face. That will be, that's why z is in the positive direction.
Yeah. True.
So if you give it negative, it will be negative negative z direction. Okay.
Uh,
So okay, blocks will be 0, 1, 3, 2, 0, 1, 3, 2, and 6, 7, 9, 8. So it has to be same, either anti-clockwise. 0, 1, 3, 2, 6, 7, 8, 9, 9, 8.
mm,
Okay.
yeah.
So in the x direction, I divided into 40, and in the y direction, I divided it to 25. So here also what I want to is on the edges, it will be like on the y direction. So I want finer mesh on the bottom and the top, and in between this face, that means 8932. I don't want it like finer mesh. I want finer mesh on uh, 11, 5, 4, 10 and 6, 7, 1, 0.
Mm.
So that's why I given here 10 expansion ratio in the y direction.
Can we read the first line again? 0, 1, 3. This is the bottom, sorry, the back and front of the lower body, lower triangle, rectangular.
0, 1, 3, 0, 1, 2, 3.
0, 1, 2,
0,
3. Yeah, it is back, and then front is 6, 7, 9, 8. We
yes.
we just divide this as a 40 division in X, 25 division in Y, and
Yes.
one division in this one.
Z. That means it will be 2D.
And yeah, yeah, it will be, yeah, 2D. Yeah.
Yes.
And then we just did it. We just give an expansion ratio of 1 that is uniform.
In the
And
X direction.
in X and in Y direction, we are asking is 10. That means,
That means, so if I have the pen axis here, pen,
yeah,
pen,
yeah,
pen, pen.
that means the mesh is expanding in
Where
Y.
is the pen? This is the pen, right?
Yeah, yeah, yeah,
So here, so here it will be finer,
yeah. Here it will be. Then,
and here it will be coarser. It
yeah,
will expansion ratio will increase. So that means we will get to finer mesh on the base of 0167.
I got it. I got both of those. Like, and then you have a expansion ratio of a 0.1. That means it will be compressing at the top edge as well. So yeah,
Okay. So edges here, there will be no edges because edges means that basically if you have any spline curves or else if you have any arcs,
yeah.
so on the pipe we will able to see on the edges part. Okay, so this will be empty, but you have to mention whether edges are there or not. So if you don't have any edges, you have to simply open the brackets and close it. Okay.
So, how do we define edges? Edges, what does this mean? Edges is like the all the lines.
So if I have like here pen is enabled.
Yeah,
So if I have like this type of curves,
yeah,
not straight line.
yeah. Not a straight line curve. Okay.
So RLC, I have any multiple points, here one point, here one point, here one point.
Yeah,
So if I have like this, I have to connect through these points.
yeah.
I have to use on the edge faces. So between 4 and 5, I have the edges. The syntax will be like if it is a arc, then it will be arc. Name the starting and end vertices point, and you have to mention the coordinates of the any one point of the arc.
Okay.
So that will come later. So after this one, we will do one simple thing. Then we will move to pipe. Okay.
Okay.
Okay. So here currently we are in. Okay, edges is completed. Boundary. So boundary on the bottom wall, 0176. This is our bottom wall,
Uh-huh.
and the wall top will be 4, 10, 11, 5.
Yeah.
Okay. So in one, that means I have given this one as in one, 0286.
Yeah.
So I want to give it in as clockwise direction and out as anti-clockwise direction. Okay.
Yeah.
So that's why I given like 0682 is my in one,
Done. Okay. Yeah.
and the type you have to here concentrate on the types. So bottom wall and top wall will be wall type will be wall only. Type
Mm-hmm.
will be one only. So there is no movement or there is no passing through this one. Okay. So in one I give it as a cyclic.
Yeah.
So okay, cyclic we will use when we have like one from one side the flow is coming, the other side the flow is going out. Then we have to use the type cyclic.
Yeah, Madhu, just a theoretical understanding, you know better than me. Is it the same periodic boundary condition that we apply basically? The flow is wrapping around. Do you have a thought?
Yes, 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 yes. Yeah, exactly correct.
Yeah, like yeah, the flow is going on one direction, exiting, and then
Hmm.
wrapping around. Yeah. Okay.
Exactly, exactly. That is the thing.
Okay.
So earlier we are given the one type called patch.
Where give a page? I can't see that written.
No,
Yeah.
no, not here, not here. In earlier cases, what we have solved. So on the one thing we given it as a patch in
Okay.
the channel flow itself, because Here there are no multiple blocks are there. In the single block, we given the patch type for the single inlet.
Yeah.
So that means patch, the type patch means it is not a fixed wall, it is not a cyclic. This is just a normal anything we can use it on the patch. So something is going out. So if you define patch here on the type wall on the boundary file, that is zero folder. Under U and P, we can define it the values. So there is
Okay.
something going inside.
Okay.
So you can search it little bit about the types of boundary faces you use it in open form. You will get like cyclic, patch, empty, and wall. These are the four basic ones we will use.
Mm-hmm.
So empty means if z direction there is no flow is there, so then we can give empty. Okay,
Uh-huh.
so this is 0682 is my in one, and
Okay.
1397 is my out one.
Okay. Yeah.
So here if we mention the cyclic one anywhere in the type, so we have to type the neighbor patch. What is it neighbor patch?
Okay. Yeah.
Okay, understand you what you said. So flow is coming from one side and it will go around and coming back, right?
Yeah.
So here the flow is coming in from 0682 and it is going out from 1397.
Yeah.
So we have to define the neighbor patch name. Here see in one the neighbor patch will be out one, for the out one the neighbor patch will be in one.
Okay. Okay. Gotcha.
Similarly, for inlet 2, that means 2, 8, 10, 4 is my inlet, which is in clockwise direction. Then it will be anti-clockwise direction 3, 5, 11, 9. So we
Oh.
have to define the neighbor patch. So for into it will be out 2, for out 2 it will be into.
So like in one, when we say is 0682, we are 17. We are clockwise or anti-clockwise? Zero.
So for in, I'm taking it as a clockwise direction.
Okay.
For out, I'm taking it as a anti-clockwise direction.
Okay. Yeah. 17. 13. Okay.
Okay, so
Okay.
if you are starting from 0, and we have to on the end side we have to start from 1 only, we can't start from 3, then it will not match patch here. So if you inlet it will start from 0, right here 0682, for example, if you take in one 0682 on the inside, so we have to take it from 1 only, and it will be anti-clockwise 1397. It can't be like 7139 or else 3971, not like this. So if you're starting from here, you have to start it from the same point on the outside, then
But
only it will patch.
yeah, but in a different direct, but different orientation.
Direction, opposite orientation.
Uh,
So you can shift it. So if you can give anti-clockwise direction on the inside, you can give clockwise direction on the outside, so there is no restriction on that.
okay. Okay.
So on the back side, so type empty means there is no flow on the z direction.
Okay. Yeah.
So 0231, 0231, side 1 of half 0. So I think I consider this block which is there on the bottom block, I consider it as a side 1. And off 0 means this is the off, and 0 means on the back side, and 1 means on the front side. Okay,
Okay.
so you can write it by using the hashtag here. For now you can understand, but later on if you see you might get confused, because off 0 here I mentioned it off 1. So 0 means on the back face, 1 means on the front face. Side 1 is means lower one, side 2 means upper one. If you can see the diagram, if you keep this diagram with you, then you can easily understand, because you have the vertices, right?
Yeah.
Yeah, so 0231 is my off, and similarly 6 7 6 7 9 8. So here I in the back side I give it as a clockwise direction, so on the front side I give it as a anti-clockwise direction. So here it will be 0231, it will be 6 7 9 8.
Okay.
Side 2, that means block 2. Block 2 off 0 means back face, this one.
Okay.
So it will be 2 4 5 3 clockwise direction. Similarly for anti-clockwise direction 8 9 11 10.
Okay.
Okay, so that's it. So we don't have any match patch pairs. That means here we are not merging it. 2 8 9 3, we are not merging this one. We just divided the block into two parts. Okay,
Good. Yeah, some edge pair. Okay. 8, 9, 10. And yeah, okay.
so now you can save it. So you can save it and run it. You can able to view it on the para view, then we can compare.
Yeah.
Save this file.
Okay. Let me save this.
No, this is text file, but you have to copy this text file, all the content in this text file, to the
So,
block mesh date.
yeah, hey, I think I already did it. So that's the reason I was thinking.
Okay, if you already so you opened the test file, right? That's why I'm asking.
Yeah.
You opened the what I sent you.
Yeah. Yeah. And this,
Okay, okay,
it looks like both are updated. Uh,
okay,
yeah, it looks like both are same. So we already, let me close save and let me close this one.
yes,
One more time, I just need to confirm.
okay,
Okay. Yeah, it looks like we already did it. Uh,
okay then.
okay.
Now you can
So
close it and
this one, yeah.
you don't. Okay, you don't have zero folder, right? In that,
No, we
if
don't.
it is there. If it is not, if it also there is no problem because we are not using the solver in the terminal itself. We are
Oh,
not solving.
yeah. So I need to run the, I think the source command, source opt open home etc bash rc. Okay, so this is ability. Let me check it. Take user ls open cd uh open home. I don't know what is inside ls. Yeah, cd deck user ls is the run cd run ls, and it was channel multi-cloud. Channel,
Yes,
channel 39 multi block ls, and now we do I don't think so. I need,
block must it.
yeah, block mesh. Yes. And
So you if you want to check, so one more thing, if you want to check the mesh characteristics,
yeah,
what is the skewness and everything, so you can just type check mesh.
check mesh. Yeah. And it will give me skewness, aspect ratio, orthogonal,
Yes.
everything there. And then I,
Because why I'm telling this one here, not earlier, because next one we are going to do the arc thing, right?
yeah.
So for that, skewness is the important parameter. You will get the results, but results are not accurate or it will might deviate. Not open form.
Oh, Terraform.
Yeah.
Should I? Oh, oh no. And
Whatever.
Terraform like this one. Why?
So okay. You just copied it. Delete. Open the folder in the file explorer.
Yeah.
Okay. So here. Delete those zone identifiers things. Keep
from
only block mesh date, control date, and decompose bar also not needed right now. Oh, keep those and delete remaining ones.
keep only these both.
That's two, and FV constraints and FV schemes, FV solutions, and whatever there on the zone part, whatever there with the name zone,
Yeah.
delete those.
Why
Decompose part
can we do?
because we
Yeah.
copied, right.
Yeah. How
If you
about,
copy, it will create one more zone identifier.
so can we keep rename this something else and rename that as a system two, or we need to delete it?
You can delete it. There is no use of it actually. If you copy from one folder to another folder, it automatically create a zone identifier.
So you mean
So
I should only keep block mesh, control dick, and FE solid?
so see here, type in the type
Yeah.
whatever identifier file is there, delete all those things.
Okay. Okay.
Similarly, go to uh, which one you deleted, system 2 or system 1?
So, let me delete this one which I create. Skip. I don't know why. Let me close
Open the system 1.
system. I just why shit rename system two. I created a system one to let me, yeah, deleted. Yeah, it takes some time. Basically, I don't know why. So we have uh not- hmm. Now we have this one.
Okay, similarly in the constant folder as well.
You
Yes.
why polymesh is there? Is okay. It's
Yeah, it's okay. So because we copied it from the turbulence, right? Polymesh comes from turbulence flow.
okay. Okay. So should I run again block mesh?
Yes.
Okay. Apply surface with edges.
And no, there is no
Uh,
running simulation is there. So you can change it to solid colors from VTK block colors too. And you can orient this one.
orient with
No. You can use the mouse. Currently, if you are using the mouse,
yeah,
you can change the direction or else from here.
yeah, from the, but it's 2D.
No, 3D.
Oh yeah, yeah,
It is 3D, but in Z direction, we are giving only one cell.
yeah. Okay.
Okay,
Oh
so if you can see the mesh on the bottom and top, so it is finer, and
yeah,
then in between the face, it is like uniform mesh.
yeah, yeah. You are right. You are right. So can we use Icofoam to run the simulation also?
You can't able to run because we deleted the zero folder, right?
We deleted it.
So we have to give in the same whatever the block mesh did under block mesh did, whatever the boundary faces names are there, you have to define each boundary face name with values and what is the type.
Yeah.
Yeah. So that we can't run with icoform. So I shared you the document, right? Open that one. So
Uh,
in the mail, through the mail, shared you the one note PDF, one PDF.
yeah. Okay. PDF. Let me.
So under last one, so these are the different types of okay, here,
Yeah.
see, that is the table. Here what is indicating is icofoam can able to run transient flows but can't able to run turbulence.
Uh-huh.
Simple foam can run both. Piece of foam also can run both. But simple foam can run turbulence flows but only steady flows, not transient flows. So whatever the solver which can able to run the transient flows, that are also able to run the steady flows as well.
But is it not like turbulence is a transient always?
No, 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 no,
I thought turbulence is a transient one always because it's like very random.
no, no, no,
Okay.
no, no, no. So here, that's why we are given the option, right?
Mm-hmm.
On the option one, transient, if the flow is transient and no turbulence, we can use icofoam. If we have a steady flow plus no turbulence also, we can use icofoam, because so solver which can able to solve the transient flows, that are able to solve that steady flows as well.
Mm-hmm.
But the solvers which can able to solve only steady flows can't able to solve the transient flows. So that's why here, so if steady is there
Mm-hmm.
and there is no turbulence,
Mm-hmm.
so we can use icofoam. But if steady is there and turbulence is also there, then you can use only simple foam.
Simple form. If transient and turbulence both are there, then we can use only the isoform or pimple form.
That also we can able to check. So if you give in place of icofoam in the in the cavity, lead driven cavity,
Mm-hmm.
so we are solving it for we are can able to solve the lead driven cavity by using the simple foam as well, and pimple foam as well, and piezo foam as well,
Mm-hmm.
because this is a laminar flow.
Mm-hmm.
There is no turbulence.
Mm-hmm.
That's why we can able to solve the lead driven cavity by changing some parameters. If turbulence is there, we have to turn it off the RNS.
Okay.
Okay, Reynolds Navier-Stokes equation is there, right?
Rents, you means, yeah, Reynolds.
Yes, yes. That's we have to change it from RANS to laminar.
Okay.
The simple changes we can make it on the we can make on the solver side. On the solver settings, we can make simple changes and we can able to run the silly driven cavity by using the uh, four types of solvers.
Okay.
Okay,
Okay.
so if you want, you have some questions regarding turbulence, right? So what are those?
No, the file is not opening. I don't know why. I thought I should show it to you when not working. Maybe tomorrow on the turbulence. So let me see, Zishan. Okay. Uh, Zishan. Yep. Contra channel. I had a file. Unexpected error. Okay, maybe sometimes next. Yeah.
So okay, so if you have no doubts, I will quickly go through what are the next case studies which are you going to solve, like in lid driven cavity.
Mm-hmm.
So I just want you to think in a lid driven cavity problem which we solve, like sphere cubical one.
Mm-hmm.
It's all same on the both all sides, right? So if you add a hemisphere on it,
Disappear.
hemisphere on the bottom side.
Hemisphere on the bottom.
So I created, I have the Fusion 360 file, but I will just want you to analyze how we can able to solve. So in any software, if you want like uh, structured mesh with less skewness, we have to minimize the circular part or else arc part. We can keep the hexagonal shape as much as possible, right? To get the structured mesh.
Mm-hmm.
Yes, right. So if you have like so many curves or complicated one, the cueness will increase.
Yeah.
So I just want you to understand how you can able to s- draw this one. Just a second, I'm just drawing it on my Fusion 360 here. Actually, my period is over, but I have 30 days period left with me. Mm, Just a second. No? Uh, yeah, just give me the access to share the screen.
Yeah, okay, let me stop sharing it. Now you can share it. Yeah.
Request elements. Can you able to see the screen?
Now it's preparing. Yeah. Yeah.
Okay, so this is the block we have lead driven cavity till this point.
Yeah.
Okay, so for that I can able to draw it. So this is the point. This is the lead driven cavity which we solved 1000 and 1000. This is in mm. Okay, I have added one arc, simple hemisphere here.
Yeah.
So for getting less skewness, I just want to minimize the number of like curves, arc or any these surfaces like this one.
Yeah.
So you can divide it into multiple blocks. How many blocks you want, you can divide it. So I just want you to understand how we can solve this problem. What is our approach?
Mm-hmm.
So how many ways we can solve it so that we have minimum arcs.
Mm-hmm.
Okay, if you solve this is one, you can directly take this is the one block and you can directly give this much arc
Uh-huh.
in the block mesh date. You will find the skewness will be more greater than one.
Yeah.
So we have to divide the hemisphere into multiple blocks, rectangular blocks, so that we have less minimized arcs. So for that one, I created like this one. If you have any ideas, you can also share. We can also try that one as well. So see, here is the sketch. See, are you able to see, right?
Yeah.
So this is the same one.
Yes.
So I divided into how many blocks? This is one,
Two,
two, three,
four,
4, 5, 6,
seven.
7. Okay.
Mm-hmm.
I divided into 7 blocks and we have to create vertices for the each point and the back face and front face of the each point, and we have to create the arc for this one
Mm.
so that the block my simulation result will be like this one. See, still I have little bit of skewness issue is there.
Okay. I can't see the mesh file. Are you sharing?
Okay, I think I shared you, but oh, why it is not opening? where it is. Okay, now you will able to see, right?
Okay, yeah.
So, yeah, this is the simulation.
Uh-huh.
After simulation, this is the result.
Uh-huh.
So here I divided into, so if I didn't give like this one, so from this point it will be like this arc only, the mesh.
Yeah.
So then my smoothness will increase.
Uh-huh.
So still have like here structured mesh is there, here also structured mesh is there. Here the skewness is a little bit is there, but we can update, you can obtain the results, accurate results. So if you can divide into even more blocks,
Mhm.
we can even get more less skewness and we can get even more accurate ones.
Okay.
So you think different options available, we will try that one. Otherwise, tomorrow I will show how we can able to run with the arcs here.
Uh-huh.
So if you're getting this one simple one, so then we can move it to uh, like pipe thing. So
Okay.
in pipe also what we can do is like we will create a circle.
And kind of like augmented mesh that we used to do.
So we have this is the circle pipe inlet. So
Uh-huh.
what we are going to do is we will divide the circle into divisions,
Uh-huh.
equal divisions, equal or anything. How many we can able to do, whatever it is required, then we can do it. Okay. So this thing, this way we can do it. And what this is a like circular thing. So how we are getting obtaining this one is like from the similar rectangular shapes. So we have one rectangle, one cube actually. Here from this one we are like connecting these things. Yeah, got it.
Yeah.
So from this one, how we are going to approach to this circle.
Uh,
Okay, that we can understand once you got this one. This is a simple one, then we can able to proceed with the same for the pipe.
okay. Yeah, good. Mm-hmm. And for the current rectangle, are we doing anything on this? Are we not?
We are going to do this one. So if you don't want this one, we can fine. We can directly continue with the pipe one.
No, no,
So
no,
if
no.
you
Go with it step by step. Yeah.
okay, okay,
Yeah,
okay then.
but I was
We,
asking about this thing that we today generated. Are we finishing this one here? Are we going to do anything on this one?
as of now, we will finish it one. Keep the files with you. Once we entered into turbulence flow, then we can solve the flow through the channel.
Okay,
Then
okay,
then I will teach you about boundary conditions,
okay.
how to create this.
Do you know anything about like create? This is just inlet, outlet, and everything. But how about creating a source thing? Do you have a knowledge of this or
Which one?
creating a source? If I want to have a source, like in continuity equation, we have inlet, outlet, plus source term, and we usually say source is zero. But if we have some kind of a source term,
So
uh,
you are generally asking about in the governing equations, whatever there in the last term, right?
yeah, suppose there is some kind of a source term here, in, having a continuous injection system, like So I was thinking, like, do we have any kind of, do you know any kind of?
Okay. User defined. You are asking about.
Yeah, 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 yeah.
Yeah, I just created. So let me show you.
Yeah.
So we don't have this one. Not here. Not here. Not here. Okay. Okay. Let me open my Ubuntu. So we calculated the air residence time. Okay.
Yeah.
So
Okay.
simply air residence time means in the COVID time, IRCTC, IRCTC Railways. So they have given one project to our IIT Bombay staff saying that during COVID time.
Yeah. Okay.
So what they are saying is they are frequently using the washroom because if previously one infected corona person is stayed for this much of minutes, so after how much of time another person we can enter, so that whatever air which is there inside when the affected person is there, that has to be vanished off from the room.
Uh-huh.
So air pass should be there. Fresh air should come. Air will circulate.
Uh-huh.
So that challenge they are given, that we run it on open form.
Do
So
you
what is,
do you
yeah,
have do you have that one to share? Show.
yeah, I have, but it is not responding right now.
Uh-huh.
So basically, what we did is air residence time. So we calculated the air residence time, how much time air can stay. So
Uh,
we designed, like we model the same like uh, washroom thing in the train in the AutoCAD, and we exported the file from AutoCAD to OpenFOAM, and we created a solver for calculating the air resistance time. Till now, we have the solvers for calculating the velocity, pressure, and temperature. These
mm,
are the only three. Um, these are what is called characters in a CFD:
mm,
temperature, velocity, and pressure. These are the only characters. From this, we can make the movies. Okay, for
mm,
calculating the drag force or calculating the any shear force. So we need lift force. We need these components, pressure, velocity. And to calculate the heat transfer, we need the temperature.
mm,
These are the major things. So for these three calculations only, we have the solvers. But we don't have any solver regarding calculating for the air residence time.
mhm.
So we created one solver. Okay, let me show if currently how I think where it is there. Yeah, you can see in the zero folder. So see here, S term is there, but you can't able to find it on anywhere in the open form.
Mhm.
So this is the solver which we created for calculating the distance time. So this is a little bit advanced version. We can do, see here. ETA time dimension is for seconds only we are given. So this is based upon the boundary field. We have to set it for everyone. So for creating this one, we have to enter into the we have to make certain changes to the one of the solvers which we have currently. For that,
Mhm.
we have to go to the solvers in the tutorials.
Mhm.
From that, we have to copy one tutorial.
Mhm.
On that thing, we have to change certain things and we have to implement certain headers and bash RC files to create a solver to calculate anything. So what do you want to calculate actually? This is also a source term which we are calculated. A resident time is the source term, right? That is typically what you ask.
Yeah. Okay. Let me show. This is power. Let me PowerPoint. Why is I won't
I
take.
shall.
too much of your time, but whatever is in my mind is also goes all like the my only problem orient. I'm like more centered to my own problem. Like all the things are going in my mind. So like even in case I have a channel flow, can you see the screen?
No, no, no. Currently, I am sharing, so you
Okay,
are not able to see
yes,
this. Yeah.
I'm honestly. So in this channel, like
No, no, no. I am not able to see it. From my side.
now you can see it.
No,
No,
I
okay,
have the video control with me, so how can I stop that one? Okay, okay, stop here. I have the option here. Okay, I stop sharing, so now you can
okay,
share.
okay. We will definitely do it once I'm just getting familiar with this one. This is my channel flow. So
Okay,
basically, my intention is like this is inlet,
that blue color one,
yeah, cyclic or any inlet. Cyclic is preferred for my case.
cylindrical. You are saying typically saying 2D or 3D.
Even in 2D, I will because it's good to go with a 2D, then to go of once I'm just good with a 2D, then we can go with a
We
uh,
can do it in next that I mean 1 week. We will do this one.
yeah,
I
yeah,
understand.
I hope so. We would be able. So I'm just trying to add a source term which can inject some kind of a solute, kind of like as in my case, the dye or the any kind of scalar quantity, and which basically goes like this one. And similarly, any kind of curve I can take. So I have inlet, outlet, and this plus source term. So you understand like I'm now have an inlet, outlet plus source term. So I'm just injecting something from here. This is not a boundary term because it's not connected to the boundary. So inlet plus source will be equal to.
From where you are injecting the source.
So in source is already there. So that's why it is called the source term because it's not connected to something. It's already.
No, you said you are injecting some particles or something like that, right?
Yeah, I'm injecting through this source.
That is not inlet then. Okay. I understand. So you are typically saying that I have a river flow.
Yeah.
On that I am adding some particles on it from the above.
Yes, you can say. Yeah, you can say.
Okay.
Yeah.
But particles we can't able to see here. That is one thing I want to clarify
I
with you.
can show it maybe in the next time if I can run a simulation on NSYS, I can show it to you. I added on an NSYS as well, and it worked. Like
Analysis, can you able to see the particles?
yeah, not particle, but what it's not particles. It's a continuous. Suppose I'm adding a liquid, not a particle. So
Okay,
there
then it will be multi-phase flow.
kind of like because both phases are a liquid, so water plus water with a different properties, you can say both are water, so not particle.
If
Particle
water with a different properties means that is another fluid, right?
yes, exactly.
Two fluids.
Two fluids they are that second fluid is basically coming from a source, because if I'm adding another kind of like a tube and another things, that becomes a very difficult to create a mesh. As much
Yes.
you keep on adding with a main geometry, the mesh goes complex and complex.
Okay. So for this one, what my idea would be like, this will be like channel, and
Yeah,
we will do one topo set here on the channel.
yeah, okay.
Then we can able to run
Yeah, first we will
because
try.
if
First in first case, I would be more interested to running the channel in 2D flow. In second case, I would like to put uh, some kind of a, you can say, bead type of thing that we need to subtract from the geometry.
Yeah, that is the typically for topo set means to subtract something for the domain.
Yeah, then like this one, I would like to do like maybe and run some kind of a simulation on laminar, then turbulent, and see the effect. And in
So
third
how
case,
much time you have?
uh, honestly, I want to learn like as quickly as possible. I don't know.
No, for doing this project, how much time you have?
Maybe 1 month.
1 month. I think it is very bit difficult in 1 month.
Yeah, maybe we will continuously learn this until I become like more like a familiar with this one. It's not like I'm doing more my experiment things. So
Okay, fine. But if you don't have any deadlines, we can definitely do this project. But within 1 month, I think it will be bit difficult for you to go through all this one because this you need to learn the topo set and you have to learn the turbulence models as well.
yeah,
And
we
you have to create the solvers on your own for finding whatever the properties you need, what are the outputs you want.
okay. I okay. That's fine. That's good. I think we will go step by step until I'm just become more familiar. I don't want to rush it so that I don't understand and keep moving. So that's not good for me as well. The main
Okay,
to understand the things. So yeah, tomorrow we will do like the things that you already mentioned. And
okay. We will tomorrow we will do that cavity with the hemisphere, and then we will quickly move to the pipe.
what pipe and then channels, like yeah, pipe
Yes.
channels, and we will spend time in that to understand it.
Okay,
Yeah, yeah. Thank you very much, Madhu. Thank you.
okay. Then you and fix that time now. So I am waiting for your call.
Yeah,
So it
sometime
will be
okay. Yeah, I'm sorry. Tomorrow, can we be like around your 10? So only for
so if only for tomorrow.
yeah, yeah, only for tomorrow. Tomorrow is
Okay,
like 2 days are like bit difficult for me, like the Wednesday and Thursday. Then
okay,
I'm much more like flexible on the rest of the days. 2 days are kind of like bit like hectic for me. So yeah, tomorrow let's
okay.
10 something. Yeah, but
Okay, for to Wednesday and Thursday we will meet at 10 and remaining times we will go with as usual 9:30.
yeah, as usual 9:30 because I don't have any other things to do on that day in the morning.
Okay,
Yeah,
okay, fine.
thank you, thank you.
Bye.
Bye.